बस स्टॉप ते तिथं सेकंड
Hello, am I audible? Hello. Hello, is my screen visible? Shall we start? Have you solved the homework problem? We have solved this example in last lecture, isn't it? And I have given one more example as the homework. Am I audible clearly? Is there any issue? Please let me know. Hello? I'm not able to hear you. Hello? Please reply. Please reply something. Shall I take the next problem statement?
Yes, ma'am.
Okay. I have already given the statement. Explain the linear probing with and without replacement using the data. Data is given as okay. Data is 12, 1, 4, 3, 7, 8, 10, 2, 5, 14, 6, 28. Okay. And assume that your bucket size is from 0 to 9. That is, table size is 10 and each bucket has one slot. Calculate the average cost per number of comparison for both. Okay. Now first concentrate on the first part of the example, that is linear probing with and without replacement. Okay. So let's assume that your hash function is key mod. Have you written the example? Or should I give you the screenshot of the example? I think I have already given in the last lecture. Yes or no?
Yes, ma'am.
Yes? Everyone? So shall I proceed to solve this example? Yes or no?
Yes, ma'am.
Okay. So hash function is, consider that your hash function is key mod 10. Key mod 10 is your hash function. Okay. So your index is from 0 to 9. So these are the indexes, and here you need to place your key. Okay. So let's take the each and every number one by one, and let's apply the hash function. So 12 mod 10, it is 2. Place 12 at position 2. Then 1 mod 10. 1 mod 10 is equal to 1. So 10 is at position 1. Then next is 4. 4 mod 10 is 4. So place at position 4. 3. 3 mod 10, it is 3. So here. Then next is 7. I think 7 is empty. Then 8. After that 10. 10 it has, here it is, it is 1, and at 0 it is 10. Okay. So after that 0 2. Now 0 2, your index is index is 2, but 2 is not empty. Okay. And first suppose consider that we are applying the linear probing without replacement. Okay. So what should I do now if it is without replacement? Yes. What is the index for 2?
Ma'am, 5.
5, correct. So I am going to place 2 at index 5. Okay, next is 5. Now 5 mod 10 is again 5, but 5 is not empty. We have already placed 2 at the position of at index 5. Okay, so next empty position is 6. So place 5 at index 6. Okay. Now next is after 5 it is 14. So for 14, yes, what is the index? Actually, actual index of 14 is 4, but 4 is not empty. So next empty position is 9. So I am going to place 14 at position 9. But now if you see that again two numbers are remaining, 6 and 28. These two keys need to be placed in the hash table, but your hash table size is only 10 from 0 to 19. 0 to 9. That means your hash table is full and you cannot insert 6 and 28 keys in the hash table. Okay. Isn't it? Now, if you want to search any key, then let's see some analysis that we have to make. The total number of comparisons. Total number of comparisons means, now suppose this is your key, and let's see total number of comparisons. This is the second part of your problem statement. The second part is calculate the average cost or number of comparisons for both. Okay. Now let's see how to calculate the number of comparisons. For 12, just wait a minute. Here first number is 12, then 1, then 4, 3, 7, 8, 10, 2, after 2, 5, 14. Here I will write some numbers below the line. 14, then 6 and 28. Okay. Now, when you applied mod function for 12, you will get the number as index is 2. Okay. So here 2 is empty, so you have directly placed 12 at index 2. So number of comparison is only 1. Got this concept? That means you got the 1 index and you have placed that value or that key at that index 1. Okay. Similarly, for 0, 1, the position index is empty. That's why number of comparison is only 1. Here for 4 it is 1, for 3 it is 1, for 7 it is 1, 8, 1, 10, 1. Now for 2, the actual index of 2 is 2, but as the index 2 is not empty, we have placed 2 at index 5. Okay, so starting from 2, how many comparisons you need to do to place 2, 2, 3, 4 and 5. So 4 comparisons to check the empty position for 2. So number of comparisons for 2 is 4. Okay. Similarly, now for placing index for key 5, your actual index is 5, but at 5 we have already placed 2. Okay. So you need to check the next empty position from index 5. So 5 is the first comparison. Next comparison is 6. As 6 is empty location or empty index, you can place 5 at index 6. Okay. So here we need 2 comparisons to place 5. Got this concept? Now tell me how many comparisons are required to place 14 in the table? Yes? How many comparisons
six.
are required to place 14?
6.
Yes,
6,
6. Exactly. 6, correct. Now for 6 and 28. Now your table size is from 0 to 9. Okay. So to place 6, you have to do the 10 comparisons from 0 to 9 until you not getting the exact position to place the 6. Okay. But number of comparisons required are 10. Same for 28. Okay. Now here the total number of comparisons are now 1 plus 1, 1 plus 1 plus 1 plus 1. Take the addition of all this. Tell me the answer. Yes. What is the addition?
39, ma'am.
39. Correct. So answer is 39. 39 means what? You can say total number of comparisons means what? Total 39 buckets get examined to place these total numbers. So how many total numbers are there? How many keys are there? Total keys are 12. So to place 12 keys in the hash table, total number of comparisons required are 39. Got this? So the mean average number of buckets that get examined per key, you can calculate this equal to total number of comparisons divided by number of keys. So total number of comparisons are 39, number of keys are 12. What is the answer? 39 by 12. Yes? The answer is someone quickly do the calculation. Tell me the answer fast.
32.5.
39 divided by 12 is 3 point. 25. Is it correct?
Yes, ma'am.
1.25. How it is 1.39 divided by 12, no? Yes, it's 1.25 still. How could you get 1.25 answer? So many people are writing in the chat box 1.25.
Then
Yes.
it's
What is the issue?
3.25.
It's 3.25, na?
मैम सभी ने
Yes, ma'am.
3.25 किया है, वो आपको गलत देकर है।
मतलब
मैं आपको 3 की
आपको
जगह
चैट
1
बॉक्स
दिख रहा है।
में 25 दिख रहा है क्या?
हाँ,
ओके, ठीक है। It's 3.25. Now, next is load density. Now, load density is denoted by actually alpha, and it is given as number of keys divided by total number of bucket size or total number of buckets. So number of keys are 12 and bucket size, total number of buckets are 10. So your load density is 1.2. Okay. So the average number of key comparisons, average number of key comparisons are total number of comparisons, that is 39 divided by bucket size. So bucket size is 10. So the answer is 3.9. Okay. So we can say that the average cost can be computed by calculating the successful search, and that search is denoted by SN. Okay. And what is the formula for this SN or successful search? Now, if you calculate the successful search, you can also calculate the unsuccessful search. Unsuccessful search is denoted by UN. Okay. Formula to find out successful search is 1/2 in bracket 1 plus 1 divided by 1 minus alpha. This is the formula. 1/2 in bracket 1 plus 1 divided by 1 minus alpha. Here alpha is nothing but your loading density. You can say load density. Okay, load density is N divided by B, that is 12 by 10. That is number of keys upon total number of bucket. Okay, so it is 1.2. So can you calculate this? Is equal to 1/2 divided by in bracket 1 plus 1 divided by 1 minus 1.2. It is 1/2, 1 plus 1 minus 0.2. So Sn is equal to, yes? Can anyone tell me the value of Sn? That is successful search. Calculate.
-2, ma'am.
Yes, -2, exactly. Now next is UN. The formula for UN is 1/2 in bracket 1 plus 1 upon 1 minus alpha raised to 2. So 1/2 again 1 plus 1 divided by 1 minus, now alpha is again 1.2 bracket square. Yes, can you please calculate this? Tell me the answer.
13 ma'am.
Yes, exactly. The answer is 13. Okay. So the total cost, can say total cost is equal to Sn plus Un. That is minus 2 plus 13, which is equal to 11. So this is your answer. Total cost is 11. Got this? Yes? Got this concept?
Yes ma'am. Yes ma'am.
Okay, I'm going to give you the notes, handwritten notes for first unit. In that, all the formulas are given. You can again solve the same problem. If you don't have any, let's go for the next example. Can I give the next example?
Yes, ma'am.
Yes. Okay. I will give you the screenshot. Let's wait. Is this visible? Can you able to read it? Please note down this statement. Actually, just wait a minute. Yes, now it's clear. Note down the example. Note down this example fast. Finished? Yes. Okay. Can anyone please try to solve this example? You can share your screen. Anyone interested to solve this example? Yes? You can share your screen to show me the answer. Okay, I will give you 5 minutes. Please try to do the first part. First, try to write the indexes for, try to get the indexes for linear probing with replacement. Okay? Yes. Can anyone please now first is with replacement. Linear probing with replacement. Okay. So first number is these are the indexes. Again function is modulo 10 function is given, isn't it? Okay, so consider the hash table size is suppose 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, 0 to 11, that is 12. Table size is 12 according to the numbers given. So first number is 24. Tell me the index for 24.
0, ma'am.
Fast. 24. Function is again 10. 4. For 13.
3.
3. For 16.
6.
6. For 15.
5.
5. For 19.
9.
9. Okay. For 20.
0.
0. Now for 22.
2.
2. 14.
7.
Yes. For 14. Actual index is 4, but 4 is not empty. And though we are applying the with replacement technique, we cannot replace 24 because 4 is the actual index for 24. So we need to search for the next empty location, that is 7. So I am going to place 14 at location 7. Okay. Now after that number is 17. Now
8.
for 17.
8, ma'am.
Yes. Now here we are applying the technique of with replacement. Now if you see, for index 7, 14 is not the actual, for index 14, 7 is not the actual index, but for 17, 7 is the actual index. That's why we are going to replace this 14 by 17. And whatever the next empty index, that is 8, we are going to shift 14 at index 8. This is the with replacement probing. Got the concept? And when you apply without replacement, in that case, keep this 14 as it is and place 17 at index 8. Got this difference? Yes or no? Okay. So after 17, so I am going to remove this 14 from index 7 and I am going to place it at index 8 and place 17 at index 7. So after 17, next number is 26. Now again for 20, your index is 6, but that is not empty, and the key which is already there in there at index 6, its actual index, isn't it? So we need to find the next empty position. So next empty position for 26 is 10. So place 26 at index 10. Now your next number is 84. So for 84, what is the index?
Ma'am, 11.
It is 4. Yes. Where should I place 84?
Ma'am, 11.
11, correct. And last one is 96. 96. Yes. Where should I place 96?
1.
Yes, at index 1. So this table is for with replacement. Now let's see without replacement. Linear probing without replacement. Okay, I will draw the table directly. Okay, tell me the numbers now again. First number is
24,
24 at 4. Next is
13,
13 at 3. Next is
16,
16 at 6. Next
15,
15 at 5. Next
19,
is 19
19.
at 9. Yes, 19 at 9, no? Yes.
Yes, ma'am.
Now next is
20,
12.
20, 20, 20.
Okay, 20 at 0. Then
Next, 22,
22 at 2. Next.
14,
Okay, 14. 14 at 7, no?
8,
14 at 7.
17,
14 at 7. Now 17. Now here we are applying without replacement techniques. That means we cannot replace 14 by 17. So what is the next index, empty index? 8. So I am going to place 17 at index 8. After 17?
26,
Yes. 26.
6,
Next empty position for 26 is 10. Next is
84,
84. 84 for index, next empty position for index, next empty index is 11.
11,
So 84, yes, we can place it at index 11. Next is,
96.
yes, 96 at position 1. So got these two techniques with replacement and without replacement? Yes or no?
Yes, ma'am.
Yes, it's easy. Okay, so let's take the next example. Now try to solve this example by your own. Is this visible? Write down the statement, please. Sorry. Yes. Completed? Finish writing? Is this visible clearly?
Yes, ma'am.
Yes. So can you solve this problem? Just try to solve it, and can you please tell me the indexes? I'm not going to solve it on the live board. Tell me the indexes. You can write down in the chat box also for each and every number. Now your hash function is mod 10. Please note the hash function. So 10 mod 8, what is the value? Yes, 10 mod 2. Oh, sorry, 10 mod 8. What is the value?
8.
2, correct. So you need to place 10 at index 2. Correct? Is it correct?
Yes, ma'am.
Yes. Now next number is 12. 12 mod 8. What is the value? 4. So place 12 at index 4. Next is 20. 20 mod 8. What is the value? 20 mod 8. Yes, value is 4, but that 4 is not empty. That's why next empty slot is 5. So place 20 at index 5. Next is 18. 18 mod 8 is equal to, yes,
2.
2. But again, 2 slot is not empty. So next empty position for 18 is after 2. Yes, what is the next empty position? 3. So place 18 at index 3. Yes. And last number is 15. So 15 mod 8 is 15 mod 8 is 7. Correct. So place 15 at 7. So this is linear probing without replacement for handling the collision. Got this? Simple problem? Yes? Is there any problem? Yes. Shall we take the next example? Is this visible? Write down the statement. Write down the statement. Yes. Can you solve this? Yes. Okay. Try this example as your homework. Okay. Okay. So should I stop today? Can you please try this example as a homework?
Yes, ma'am.
Yes, ma'am.
Okay. So let's stop today. I will give you the link for attendance in the chat box. Just wait a minute. Should I stop my presentation? Have you noted the example?
Yes, ma'am.
Okay. Just give me a minute. Attendance link is there in the chat box and your code is just give your attendance and then you can leave.